In our today's video, we are going to learn how to use a selective switchgear to control your voltage supply from different positions. That is to control from different sides, and also how to use different voltage supply to control your output load. Now let's see how the connection is being worked. And as you can see, selective switchgear is a switch that gives a voltage supply at a particular direction, keeping the other side of the supply isolated. And when you keep it at 0, it means that the two phases of the supply is being isolated. 2 means that it's only the voltage that passes through the connector of line 2 that will give out the output voltage supply. And 0 means that there is no voltage supply. It means that the two phase is being isolated. And 1 means that it's going to give an output supply and is connected to the line 2, so that if anything is connected to line 2, it's going to give an output voltage supply. Now let's see how the operation is being done. So before checking the operation, you need to test each part of the rotatory switchgear to know how the terminal is being connected and where it's being isolated. Now let me use my digital multimeter, so I will tune it to on, so that I will know when it's connected and when it is not connected. So as you can see, that is my digital multimeter. So here the on means that it's connected. Now let's see how it works. So I'm keeping it now at 0. So I'm going to test each part. So 0 means that this is isolated at 0. So I'm going to test this part. So it means that it's isolated. Therefore means that whenever you keep the position at 0, there will be no voltage flow from any point. So after testing the 0, so we'll now tune it to 1 to check which side will be the direction of voltage flow, current flow from the selective switchgear. So now I've tuned it to 1. So I've checked from here. That is not where the phase is being connected to. So I've checked from this side. The on means that this is where the phase is being connected to. So that means from here to here is not reading, means that here to here is being isolated, but from here to here is connected, here to here is connected, and here to here is connected. Therefore from here to here is connected, here to here is connected. Therefore means that if you put an input here, this is actually where you get your output from, and if you put your output here, this is where you get your input. So now if I turn it to this other side, which is the 2 position, it means that it's isolated. It has totally isolated the 2 position, and the 0 also will not be working. So let me tune it to 2. No, initially it was at 1, and that one was when it was giving supply to this side. So if I turn it to 2, I will turn to this other side. Then as you can see, it's giving out supply voltage. Now I want to use a single phase supply, but to control different load and at different positions. So that is the supply. I'm keeping it at 0 now. So let me do the connection together, one after the other. So I'm going to loop from this point to this point. I call that a neutral. So I'm looping from here. So that is a neutral. That therefore means that whenever I put my main neutral here, I've connected it to this side. Therefore means I've looped it to this side. Why I'm doing that is because I'm using a single phase, whereas this thing is 2 phase, so or 3 phase. So if I wanted to use different supply, I would have put a single neutral here and put another neutral here, meaning that I'm using different supply of voltage. But this one I want to use single supply, but to control different load at different position. So that's why I slot it there. Therefore means that if I put my input voltage neutral here, it's going to loop from here to here. That is giving the neutral to this other side. I'm going to do the same thing to the live. So I want to slot the live terminal at this point. So this is my live. So I loop it to this other point. This simply means that whenever there is a voltage flow from this part, there is also a supply to this other side. So this is my phase 1 and this is my phase 2. So this is 2 and this is 1. So if I input here, it means that we'll get the output here. So the output that is here have been looped. If the input is here, it means that if I input here, we'll get output here. So that input have been looped down to here. But in the case that you are going to use a generator and a NEPA supply, you put your generator input here, you put your NEPA supply input here. But in this case, I want to use a single input and get different output. So the different output will be coming from here and it will be coming from this point. So let me bring the input from the NEPA supply. In this case, I want to use the input from the NEPA supply. So this is my input from the NEPA supply. This is the input. I've looped it already here. So I'm going to detach the one that was there already, since I've already looped it at this point. So I'm going to remove this one. All right, I'm done with that. So I slot this one in at this point. Then I slot this one in. Okay, instead of that, let me loop from this point to this point. That is my input voltage. So I'm looping from this point down to this point. Therefore, I'm getting a supply input from here to input from this other side, so that if I'm turning it to 2, the 2 will automatically get an output also. So I've now gotten my input. So assume this input is from generator and this input is from my NEPA. So this is the input live from generator, this is the input live from NEPA, for instance, but I'm using a single input to get the 2 inputs. So this is my neutral. I'm going to do the same. So I'm going to bring my main neutral in here. So this is my main neutral. All right, so I'm done with that. So the next thing is for me to get the output. So this is the output for this side. All right, so this is the output. If I keep at this point, this will be the output for here. So if I'm turning it to this point, this will be the output for it. So now let's do the connection. You know that the lamp is going to be our load. So our load is where the output is going to connect to. So the output is always our load. So let's connect the output. So this will be my output. So I'm going to slot the phase lamp here. So I'm going to slot the phase lamp here at my output phase 1. All right, so I'm done. So I'm going to slot the second lamp. This is the second one. So I'm going to take the second lamp to the second phase. So this is the second phase. So I slot it there. I'm going to screw it down. All right, so I'm done. So this is the neutral from this phase load. This is the neutral for the load output. So I'm going to connect it here. All right, I'm done with that. So the neutral for this other phase, I'm going to also connect it at this point. This is the neutral for this phase, so I'm going to connect it at neutral. So this is my neutral for this phase. This is a neutral for this phase, so I'm connecting it at this point. So the 2 lamps has been connected to the switch gear. So our input live is here, has been disconnected, and this is my input neutral. So these are the output. This is the live. And this is the neutral. That is the neutral main input. So that is it. I'm done with the connection. So I'm going to insulate this point. All right, so I'm done with that. So the next thing is for us to power the circuit and see the operation. So let me power the circuit for us to see how the operation will be done. So this is what I'm using to power the circuit. I'm using this to power it. So you can see this is my input load. So I'm going to use this to power this circuit. All right, so the position of the switchgear at this point is at 0. So we are going to turn it to 1 to control lamp 1, then turn it to 2 to control lamp 2. Now let's see how it works. So I'm turning it to 1 to control this lamp. So if I turn it to 0, it has off it. Therefore means that it has off the isolate the two sides. But if I turn it to 2, it's going to turn on this one. So I've turned it to 2 to turn on this one. So I turn it again to 0 to turn off the 2, and this to this. So this operation can also be done to know when it's automatically controlling a circuit. You can keep it here as an output, but when you want to control a circuit manually, you can control it from here. But if you don't want to control the circuit at all, keeping everything isolated, this can just be like a TPN junction, so you can keep it at 0. So I hope you understand the video very well. If there is any question, drop it at our comment section. Thank you.